Okay, so the most important thing to know is to treat this question as basically just finding how this is transformed from your standard graph of sine x, right? Now, thanks to CJ, we know that the amplitude is equal to 5 and the period is 2 pi like it normally should be, and that there's a phase shift to the left of pi over 3. So, yeah, thanks, CJ. So, this is the answer. And here's why, right? So this 5 here, that takes care of the amplitude, making it, 5. The period's 2 pi, so there's no need to have a q value. Q value is 1. And the phase shift is pi over 3 to the left, so you put that as the r value. Okay, moving on. So basically, two-step question here. You got to find the derivative of f of x, and you have to find where it's equal to 0, right? So we have a couple of ways to write out f of x, and the derivative. I'm going to start with this one here because it's illustrative of something important, right? Now, the derivative of any sinusoidal function is basically going to be the same sinusoidal function shifted back a quarter of a period, which in this case is pi over 2. The practical application of this is that the derivation of sine x is cos x, derivation of cos x is negative sine x, derivation of negative sine x is negative cos x, and the derivation of negative cos x is sine x, and all cycles around for every 4 iterations. And so we get this I want to click. There we go. We get this value for the derivative of f of x, right? We get f of x equals 3 cos x minus 4 sin x. That's not very useful for our purposes, but that's just an illustration, right? Derivative here, because it's basically, as we know, like 5 sin x, is just, we could write this out as 5 cos x, but I think it's easier and just more illustrative to just phase shift it pi over 2 to the left. So you wind up with this function, with 5 sin x is x plus 5 pi over 6, which is just pi over 3 plus pi over 2. It's 5 pi over 6. And so because of this, you wind up with an x-intercept value of negative 5 pi over 6. And as you can see here on this graph, which I've almost managed to get superimposed, the initial function here that I'm kind of tracing is just phase shifted to the left when you take the derivative. It's the same function, and like 5 pi over 6 is right there where we expect it at about, I don't know, negative 2.5 or something. But yeah, it's where it's supposed to be. It's less like graphical confirmation. We're not completely wrong. But more importantly, the important thing to know about this question is just that the derivative of sinusoidal function is just phase shifted according to period to the left. Applies here. Same with the x-intercept. Okay. Because like this point got moved to this point by pi over 2. All right. E. Two values of k for which the question f of x equals k is exactly 2 solutions. So here's a graph of f of x again, right? And we've already got it restricted in the domain that we were given. So as you can see, like if you draw a horizontal line like through this, it's going to have like, four values of k. Of course, there's going to have f of x equals k is going to have 2 solutions. It's 4 solutions. Up here, it's going to have no solutions. The only point which is going to have 2 solutions is right here where it touches the extreme highest or lowest values, right? So because the amplitude is 5, k is obviously going to be equal to 5 and negative 5. Thank you very much for listening. This concludes math lesson.